Okay. I think I'm gonna start. Twitch might have a little problem. Maybe it says it's unstable. Keyframe interval too high. Bitrate is red. I don't know why. Let's see. Well, that's not what I want to show. That's fine though. Yeah, not a lot of new changes. The only change I think I made stream-wise is that I'm using a new microphone. Probably shouldn't have tapped it, but hopefully this will make my voice a little more clear. At least when I recorded it, it sounded a little clear. The only downside though is that you hear my keyboard a lot more. So yeah, let's see, I wanna turn this up a little bit. Yeah, okay, we'll keep it there. All right, so I still haven't verified the data like I said I would. Yesterday I was very low energy. So Python, will not work. Train. Yeah, okay, cool. So yesterday we finished getting our data all prepped. We stabilized it, removing seasonality between it. And then what else did we do? Oh yeah, we had to scale it correctly. Before I was scaling it, giving the test data an unfair advantage. If you include the test data as part of your scaling algorithm, then that kind of gives the model a bias. Yeah, so we ended up scaling the data on the training data, and then keeping, here, I'll just show it. It's a lot easier just to show instead of trying to remember and explain. So yeah, we have the prepared training data, and so that'll take in the bars of the training data. So that's just whatever's in the CSV file. And then it will calculate everything like we did yesterday, or I guess day one, we did all of this. Yesterday we made sure that we can get it all back to our normal price, our unscaled price. And then here we guess it's not up to do anymore. That's just what we're doing. Then after we scaled everything on the training data, then we put it back into a supervised learning problem where column 0 is the input and column 1 is the expected value. We'll use that for training, just calculating our loss function, making sure that the model learns. And so here we do what I said. We return the parameters that we need for scaling correctly, which is the min price, max price. And so we can take those into our prepare testing data, and we do the exact same thing as the training data, only it's A on the testing data, and then B, we're using the scalars for the training data. And this might make it so our data is not in a 0 to 1 or a negative 1 to 1 scale, but I think that's fine. So yeah, that's a recap on what we've done the past 2 days. So today, hopefully I don't have too much time. Those were two sentences that I was trying to merge in one. Hopefully we'll get it done. I don't have too much time. I only have about an hour. So at the end of yesterday, which is the last stream, day 2, I was starting to kind of model out what the model would look like and what we need. And keep in mind, I'm not an authority. There's probably a lot of other people that you can watch. And it's super distracting. Sorry, like the music that I'm playing is Stream Beats. Check out their stuff because I believe it's copyright-free music. But if you go into it's Stream Beats, and I'm viewing it through YouTube, and I had it up on my other monitor, so like when it changed the song, it would like refresh the video and to play the next song, and I was just like, what is my computer doing? Okay, so we're starting to get the model done. Yesterday I did a little bit of model stuff. We have our very, I don't know what to call this, very accurate, very sophisticated and very very strict naming conventions of herp. So we have a herp, which is just a, whoops, I did not want to delete that, which is just a batch of our training data. I think this is how we're going to batch our training data. I honestly don't know what hidden is. I think that's like the hidden layer for the LSTM. I don't know why the long short-term memory model has like has it outside of like the model, whereas with a traditional neural network or a deep learning neural network, you just have all the layers here. This is kind of a bad example because it just has like the input, this 400 hidden layer, and then the output of 4. But yeah, normally you just have all your layers kind of like specced out there, and this hidden layer seems to be just outside of the model, which is interesting. So yeah, here I was talking about, I might not do this, but last time on stream I was thinking that the model would have knowledge of the min and max price, so we can get an actual usable number. But then I remembered that it might get a little more complicated than that, and then I'd also have to do some conversions with the expected output in our training and our test data. So I might not do this, but anyway, I think this model is probably going to be fine. Yeah, I'm just going to get rid of this for now because we're just going to, whoops. We're just going to keep the model in model space. So the model is just going to take in that scaled value, the scaled input value, and then it's going to return a scaled expected or predicted value. And then we will convert that outside of the model. We'll convert that to a usable price value, and then we will compare that and send the predicted value and the expected value in non-scaled form into our loss function. Okay, so what I want to do here is I think I'm going to get rid of this, and we're just going to simply test that I made that LSTM model correct. Oh, I need to import that. And then batch size is 10. And then let me go. Oh, I already did. I want to do, I believe. Oh, well, here, let me finish what I was doing. And then we'll relearn Python. Dang it. Oh, wow. I cannot type today. Let's see, train. Yeah, 0. And 10. Ah, yes, the error. Oh, yeah. That's right. We don't. Hidden is inside the model now, so we don't need that. And actually, it's not a function anymore. We need to just call forward. Oh. Oh, and I need self. LSTM, which is the function, and self hidden. Yeah, okay, that should work. Nope. Oh, we don't return anything. And we don't have hidden. Cool, okay. The numbers don't matter right now because we're not training them. Actually, what is this? Is that the herb? I guess I can just pass that in. Dang it. Okay. So I can just rename this. Whoops. Rename. Okay. Okay, now we're going to write the train function, I think. So all this other code is just code that I've had before that trained the previous neural network, which was just a deep learning neural network. I guess it wasn't really deep learning because it just had the one hidden layer. But anyway, semantics. It was a neural network, not a recursive neural network. So probably going to get rid of this. Actually, I might be able to remove some code. I'll do that off stream. Let's see. Yeah, I think that's fine. Okay, so for training, I think I just want to take this stuff and we're going to put it into a loop. Maybe not that. Yeah, take this. Yank that. P. How did I batch? So I'm worried that at the end of the batch, oh, maybe I just have to truncate data. Because as this, so the model here wasn't aware of the batch size, we just had views, right? And this is the deep learning neural network, how it trained. And so here we can just fill half a batch right at the end. We're just like, oh, we're at the end. We just make batch size whatever's left, and that's fine. But because we take in a batch size, oh, and then we don't use it. Oh, that's just for hidden though. Interesting. Okay, well, what if so this should be batch size. Maybe I don't want to do it like this. Huh. Oh, geez, that is bright. Oof. I'm gonna read some more docs because I don't necessarily understand hidden. So I don't know if we need hidden size. Like, is that something that needs to be a part of the model? Because what I'm debating, so like, since hidden size is dependent upon batch size, or the hidden layer is dependent on batch size, I'm wondering if while we train in here, like we take hidden outside of the model, and then when we train, we just make the hidden state, right? Let's see how they train. Because if they keep hidden, okay, so they have a hidden dimension. Alright, I'm unsure. I think I'm just going to keep it in, I guess. Then I will... I guess we're just going to truncate it. Okay, we're probably not going to be editing this too much. Give me 2 seconds. I'll be right back. Okay. Didn't even mute my mic. Okay. Oh, that didn't help. Had to put eye drops. Had to put eye drops in my eye. Wasn't seen very clearly. Might be a little too late to do all this. It's fine. We push through. Alright, so I guess I'm just going to shit some stuff out, and then when it's wrong, I will know when training doesn't work. So we're going to truncate our batches since the hidden output is basically dependent on the batch size. Instead of doing what we did up here, or what I did up here with the kind of like a dynamic batch size, we basically just made a tensor on the fly and like filled it. We made a tensor on the batch size and we just filled it with the data that we were feeding in. Because the hidden layers are dependent and I don't understand enough to know if I should be modifying, like doing a very similar thing with the hidden layer here, we're just going to keep the hidden layer as it is. Because I think that's where the memory comes from, like that state helps with like the long short-term memory portion of it. But I don't know, so we're just going to keep it and we're just going to truncate the data, meaning that basically if this happens, we're just going to return out of it. I'm going to do it a little more eloquently, or I'm going to attempt to do it a little bit better than that, but okay, so let's see. Do I want to do loops? Yeah, so batch loops. Yeah, I probably just want to do that. And, oh, I need to do size. Yeah. Length of data. And we're going to do int size divided by 10. How did I figure out batch size? Oh, I just made up a number. Cool. Yeah. Yeah, I actually probably want that in a variable. That might be, I might turn that into a hyperparameter just because I have to feed that into the LSTM model. Yeah, then we can do for, do a nice little for loop. I in range. Do I want batch loops like -1 for the truncation, like I said? Actually, you know what, we're just gonna, it's the first thing we're gonna do. We're gonna figure out what our batch loops should be. I and then size of data we also want to know. Whoops. Oh, let me go. Oh yeah, we should actually call the method as well. That would help. Oh, I think I wanted that. Just kidding. So that I want. And then we're going to say train. Oops. Train data. LSTM model. Oh, shoot. We're just going to use L1 loss and L1 optimizer. Okay. Whoop. Oh, it's just called L1. Okay. No. Oh, yeah, it is. Probably not going to use those. I may or may not use those in the real one. I'm just shoving those in so Python doesn't yell at me. Oh, and it still yelled at me. Shit. Oh, yeah, that's right. Let's see. That's fine. I don't need that now. Okay. Oh. Okay. All right. So that was 2 because our data is 4. So it's the 2 columns. I forgot about this. So it's the 2 columns that we have. One being the input, or sorry, the first column being the input, the second column being the expected output. And then our size is however much data we have processed in our CSV file. We don't know that at compile time, interpret time. And then 4 is just how many features we have. And we just know that. So yeah, so what I'm doing here, or what I did before, was I did the length of this first little bit here, which gave back 2, which is not what we wanted. We wanted this. So now I'm going to do data of just the length of that first column, which those should be equal for both columns. And we'll see how that goes. Okay, perfect. All right, and so I didn't actually want to do that yet. Okay. Oh, we don't have to truncate data. Our data just so happens to fit perfectly. So that's nice. That's good. That was a happy accident. So yeah, so that's just because the time period that I chose to get, and this is just for the training data. This might be different for the testing data, but the time period that I chose to get for the training data just so happens to fit in a batch size of 10. If I got any other data, like an hour 1 data or like daily data, might not have fit perfectly into this. So for now, we're just gonna say praise be, that worked. And then, oh, can I do, what do I want to do? How do I want to do this? Yeah, no, so our batch is just going to be the data, the input, because it's 2 columns. I think it's going to be I times 10, and then we're going to go to I times 10 plus 10. Batch. I hope I can do that. Fuck. Oh, yeah, I used the wrong thingy. How do I get into a assert like that? Neat. Oh, not neat. Did I math that wrong? Shit. Did 10 not fit cleanly? Hello? Can you hear me? So 0 counts. I don't think I anticipated that. That's fine. We'll just say that's not the data though, right? Sure, that's fine. Okay, nice. And then I think we just try to get our output from model. Just call it model and give it the batch. Yeah, no, we do model.forward. I don't know why I have to like really save. Oh yeah, that's right. I need to do the as tensor stuff because that is a NumPy array. I have to view it in this format. And hidden is within the state or within the model. Yeah, look at that. Let's print the out. Oh, that's a lot. So much data. Nice. Yeah, it tried to do a thing. Look at it. Look at it go. Neato Toledo. All right, so now we probably need to make a function to undo the stuffs. Or do I want to be lazy? I don't know if it's better to keep things for the loss function. I don't know if it's better to keep things in the scale. And the scale of the model. That's what I did up here. In this old model, I just left it and then I translated it later. Like actually I think a different program or a different script that I had like translated it back out of like the scaled space into like the price data, the human usable space. I don't know enough if that's good or bad, or if that's a thing that should be done or not. Yeah. I'll have to see what that keyframe interval too high thing is. Because that's weird that Twitch is just not happy. Well, that's fine. Oh, that's distracting. Should not be doing that. Okay. So look at the out. We just need to grab our expected. So the expected equals data 1. So it's going to be the same thing. Times 10 I times 10 plus 10. So same thing, only the other column. Because remember, and I'm not really reminding you guys, I'm reminding myself, because I already messed that up today, is that the 0th column, the first column, is our input, and the words, the second column, index 1 is our expected values. So now we do loss, we call our loss func, then we have our out, and then our expected, and then optimization func step It's a lot of typing. Grad. Loss item. Loss item. Average. I need to make that variable. Or do I? Cool, if this works, then this is pretty similar to the deep neural network. Oh yeah, I wanna should just use L1. Ow, it's bright, sorry, I should have had a warning. NLL loss? I have no idea what that is. Negative log likelihood. Oh yeah, I remember that classification. We're not doing classification, we're doing regression. So yeah, I think I'm just gonna keep those same losses. I'm gonna make my own function because they're using the L1 model. Well, I guess that can be used. The optimizer I'm going to change. No, I'll call that Adam. Yeah, sure, learning rate 1e to -6. That is fine. Ah. What? Int object is not callable. Oh, is my expected? My expected, I think, needs to be. Is that what I did up here? Ah, yeah, as tensor. Yep. Good old as tensor. Oh, you know what? Shoot. How is this given to me? Okay. Oh. Should I make that a 1-1? Oh, maybe that's the problem. Maybe it shouldn't be a 1-1-4. Maybe I need to flatten the output. And also this. We'll see if it yells at me. Oh, okay. Yeah, okay. Size 40. Maybe I did too much too fast. Hold on. Let me we're gonna get rid of all of this, and we are going to print the expected, and then I think f shape, out shape equals expected shape. Oh, those are functions. Whoopsies. And these are tensors, so I'm pretty sure they have the shape function. They do not. I'm a fraud. Torch size. Oh no. I thought it had a shape. Does it not have a shape? Am I crazy? No. Ow. Shape. Oh, tutorials. Yeah, they totally have a shape. Oh, size. Oh, okay, so it wasn't a function. I was wrong. That's neato. Oh, look at that. Okay, well, they're not the same shape. Oh, yeah. Okay, so the expected is like this. Okay, and then there's a flatten, right? Yeah, flatten. Torch flatten. Is that what I want? Do I just want to flatten both of them? Let's find out. Does flatten return a new one, or does it? Oh, okay, I have to call it on the object, and it modifies the object, it looks like. Oh no, okay, so it does return. Okay, yeah. Okay, we're just going to assume that the other 17,000 are true as well. Sorry, 17,080. Okay. So now that should be able to work. I'm just going to enable all this. Whoa. Nice. That was pretty fast too, which is also nice. Because my old one took about 10 minutes. Oh wow, you definitely need a couple epochs. Because this is, oh, do I not want to flatten? Ooh. Oh, do I just want to flatten them? Oh, that might not be right. We're gonna get rid of those. Because they're completely flat now, which I don't think is correct. I think we want, I don't know how we exactly want them, but I want them to be still in the groups for the time series problems. So we made them completely flat, so all 4 of our features that we're trying to predict aren't like grouped together in time series. In our time series, they're just all flat, so it's just one big array, and I don't want that. I want 2 thing of array. Oh, does the stream stop? Oh, that's bad. Maybe I need to restart my stuff. Maybe it's all on my end. The stream should not be stopping. Let's see. YouTube thinks it's healthy. Do I have internet? Uh-oh. Go to my blog. Yeah, I have internet. Okay. Okay. Interesting. I think I am having some issues. I will resolve those tomorrow because I don't intend on. Probably not going to stream tomorrow. I'm probably going to stream. Uh-oh. Hey. Internet? Uh-oh. Maybe my computer's having problems. Uh-oh. Huh. Well, the good news is I'm streaming to YouTube, so whatever YouTube gets, it'll be on the VOD, so hopefully it'll be better. I'm unfortunately not recording this, because I just, in my hubris, I was just like, oh yeah, YouTube will get it. I don't need to do anything. But yeah, I might be having some technical difficulties. Shoot. Let me try to pound this out real quick. And then I will end the stream and then try and maybe fix the stream by, probably fix it tomorrow. I'm not actually going to stream tomorrow. I'll probably stream Wednesday again, probably in the afternoon, unless I can wake up super early, which I doubt I will. Okay, yeah, I think I also want to start Dem 1. Oh, they're false. Well, I guess it should be. Okay, so that's fine. I think, no, that's not fine. Oh no, yeah, that's fine. That's what we want. And then we just don't flatten expected. Expected is fine. And they should be the same shape. But not the same shape, fuck. 2, 3, 4, 5. Oh, maybe I want 0. No, I want start then 0. Whoop. 0 and dem to be 1. Yeah. Cool. Okay, and that's fake as well. Did I not? Oh, okay, yeah. I was like, what? Okay, this might be just the end. We'll do epochs later when we get the testing done. Cool. All right. Does learning happen? I guess for that I need to. Whoop. Yeah. Oops. Wrong language. I100 0. Is this correct? What is this? Oh, I guess that would be way easier to see if I didn't output something every. Oh no. Okay, well. Okay, yeah, we know that's that's fine. We know that's fine. Learning does not happen. Okay. So something's not correct. I think we're going to do that tomorrow though, because I might be having some stream / internet / computer issues. So I'll end it here. We got very close. We took what we learned yesterday with the batches, being able to batch it and run the neural network, and now we're starting to, and we're very close to getting our training up and running. So today we wrote this function basically. So we'll come in here, gather data, calculate our batch size for our data. We'll go through the batch loops, and then we will, oh yeah, maybe I do need b-1 because then it'll truncate that last one, which has not full data, but anyway, whatever. So yeah, we collect information about our batches so we can iterate through all of our data, and then we'll go and we will gather our batch with the appropriate batch size. Then we will get a prediction from our neural network, and then we will flatten that to get rid of a dimension, basically because the neural network is batched. We have it structured in a way that it's a 3-dimension tensor, but we want a 2-dimension tensor. So we do that here with flatten, and then we gather, or we construct our training data, or our evaluation data, our expected data. Yeah. And then we go through and we do calculate the loss, do the optimization. Oh shit, do I do, what is that thing that needs to be done? Model.train. Yeah, do I need to do that thing? Mostly random. Okay, well, that's fine. Yeah, so where was I? So yeah, we also calculate the loss, which might not be working correctly, and then we do the optimization, which again might not be working correctly. And then we get our loss, we calculate our loss. So we have a trailing average loss, and then we calculate like the loss for this batch. And that's just, I basically only print that out just to make sure that like the model is learning correctly, and then I will stop doing that per batch, and then I will go through epochs. So then I look at the average loss for that epoch, and I'll be like, oh, we'll do 10 or 25 epochs or whatever. But we're not there yet because we still have to make sure that training works, and then we have to make our testing loop as well. So yeah, like I said, this is it for today. Made some good progress, got the training for the recurrent neural network. Yeah, I will see everyone later. I'll try to wave this time. Okay, yeah, it picks it up. Bye-bye.